Today, I'm going to try to share with you some ideas that I had in mind for a couple of months and work on this project for a while. It's about JavaScript code quality. So a little bit background about myself. I'm a more like a C++ guy. I work on projects like KDE, Qt, WebKit for a while. And then when I transitioned to work for a company called Sencha, we produce tools, framework, and libraries, cloud services for web apps. I realized that, in front-end development, especially when you start to build apps using JavaScript, there's still a lot of room for improvement. There's still things that needs to be better at, particularly on the language tooling itself. And therefore, I set out to explore a bit what we can do to improve that situation. So how many of you here works on JavaScript project alone? I assume the rest is working on a team. For the rest, how many of you plan to grow your team? Yes, a lot. So as the team grows, your application becomes more and more complicated. Bad things start to show up. For example, from the previous talk, we heard that people start to copy and paste code or try not to draw anymore, and that causes a lot of problem. One particular problem is how do you track the code quality over the time? How do you have the confidence that the version that you ship right now doesn't regress compared to the previous ones? So a trend that I start to see more and more is that people apply something what I call as multi-layer defense. So basically, you surround your headquarters with layers and layers of defense so that you try to protect the bad guys. So how many of you use IDE or editor with JSLin integration? Yeah, that's some sort of defensive mechanism that you place upon yourself so that you don't write the bad code. It will be very terrible if you build, mail application and before you try to launch your extensive test suite in a Selenium grid, people cannot log in. So what's the purpose of doing extensive tests? Same case if you build e-commerce sites. Before you analyze the performance, you have to make sure that the site is very, very usable from the moment people visit that site. So we can place all these layers in different strategic points. Build tasks if you use Grunt. How many of you use Grunt? All right, cool. Or if you're still stuck with AND. Code editor is another place. Pull requests. Travis CI has this fantastic test integration where if someone creates a pull request, the patch is going to be merged in and then run against the test suite, and then you can immediately know the status. CI server as well. How many of you here use Jenkins, Hudson, TeamCD? So CI server is another place where you can put a lot of protections. Smoke test is pretty important. As I mentioned before, what's the use of a mail application if you can't log in the first place? VCS hooks, I'm going to show a way to inject some testing right into your git pre-commit hook script. So one thing that people forget is that feedback is very important. So if the tool says to you that, hey, this is the problem with your code, and there's no feedback whatsoever, then it's very difficult to improve, especially for new engineers or interns or whoever just joined the team. It's very important that you get some sort of concrete feedback as to why that things were not accepted. Quality metrics. Just like any other numbers, we don't always take it as face value. The best way is to cross-relate it to another metrics. The most obvious example is by tracking this in a two-dimensional form. So, for example, if you care about performance, then execution time needs to be plotted against the application efficient. So every check-in, there should be a test suite that launches the performance test and then give you some numbers. And if you plot this against both x and y axis, your y means time, then over the time you know if something regresses or not. So this is also a very easy way to find out if something is wrong or some people screw up and commit some code that slows down everything. So metrics is also important in the sense that sometimes it's not the destination per se. So it's sort of a journey. So in this blog post, I describe the story where if you start with high performance code but badly readable, then you want to improve its maintainability. On the other hand, if the code is very readable but you cannot improve the performance, then you need to place certain metrics like the previous slide, where over the time you can refactor the code and then improve the performance. I like this, the big rock philosophy. How many of you here heard about this? This is from the book from Stephen Covey, First Thing First. So the idea is that if you want to solve a lot of problems in the world, it's impossible given the time constraint, but you can try to solve the big problem first. So if you try to place all these rocks in a jars, and pebbles and sand, the easiest way is to put the big rock first, and then the pebbles, and then the sand. That way you can fill the jar more optimal. So let's talk a little bit about what kind of foundation we need so that we can build such kind of tools. If you look at how JavaScript works in the browser, JavaScript engine is just one of the components there. You see the user interface. This is the browser interface that you interact with day to day. And down there's a browser engine that also deals with, like rendering, because you might have CSS and etc. Obviously, there's networking I/O because you need to fetch the data of a remote server. And if you write code, then it will be executed by the JavaScript engine. And if we look at various JavaScript engine, there are different numbers of engines out there, and the open source one are the one printed in bold. So looking at the source code of this JavaScript engine sometimes give a better insight as how things work there. And in a nutshell, basically your JavaScript code will be consumed by a parser, and the responsibility of this parser to construct something called abstract syntax tree. And then it gets executed in the virtual machine AK interpreter. And in some cases, you need some runtime libraries because you want to work with string, array, math, and etc. So the parser itself does things in two steps. The first is tokenization. This is just to break your source into tokens. So in this case, in my simple one line of code, the engine knows which one is keyword, which one is an identifier, etc., etc. From this, it constructed the syntax tree. This is another data structure that allows the JavaScript engine to understand the semantics of your program. So in this case, it's just variable declaration. There's an identifier there. Obviously, it's called answer, and there's a literal constant. So if the virtual machine or interpreter execute this, this tree represent a rough understanding of how things get executed. So it will declare a variable, and it's called it answer, and assign a value called 42. So syntax visualization. So sometimes it's difficult to understand how the engine construct the syntax tree. So I built this online parsing. It's already mentioned in the previous talk. This is Esprima, a JavaScript parser written in JavaScript. And one of the things that you can do with it is to analyze your code, your source code. So if I write var answer equals 6 times 7, this is the syntax tree formatted as JSON. And it's a tree, so another way to visualize it is by a real tree. So you can see that there's a program body there. It has one now things will be cut because this is responsive web design. Better? Yeah. So whatever you type here, if I go to my previous examples or make it the variable declaration, then you have the sort of estimate of how the JavaScript engine sees this particular code. So once you have the syntax tree, we can do a lot of things, and that's exactly what the rest of this spreadsheet all about. So this is kind of inception. Once you already have the syntax tree, you can execute it in the browser, and then you can visualize the execution. So there's a nice project called Meta.js, which implement a JavaScript interpreter with JavaScript. So if I write this simple loop and I run it, then it will go through every statement, every expression, and execute it, and then visualize it. Is it visible? The yellow highlight on my editor? And then you can see what happens with those variables. So obviously, I is incremented every time, and y is the square of i's. I can watch this all day long. It's really fun. You get the idea. Even further, we can also do live editing, live coding. So it's a very nice project. So on the left side, it's just canvas, and on the right side is the code. So the code is what makes this particular shapes on that canvas. And normally, you can change the code by typing, but I think this allows sliders as well. So you can change the value here, and the code will be executed live. So you don't need to type something, reload, and do that stuff. So in the world of language tool, there's something called composition. So the idea is that tools should be composable. Instead of one giant monolithic tool that does everything, we should be able to pick and choose which kind of tools that we want to use. Kind of like framework versus library in the web world. So for example, I already mentioned about parser. The job of the parser is to consume the source code and then create the syntax tree. But we can have another project, code generator, that takes that syntax tree and generate the source code. Obviously, they might not be the same. And in the middle, we can insert syntax tree processing. An obvious example is this minifier. How many of you here are using minifier? Uglify, YUI compressor, that kind of tools. So what it does is parse it, modify the syntax tree, so try to minimize the size without affecting the functionality, and then regenerate the code. So minifier, if you take it as one tool, is very monolithic. Something comes in and something comes out. But there's a new trend where you can start to combine these tools to suit your purposes. So once you have this parser, once you have these extra tools around it, and then you can compose them, then the possibilities are endless. You can build inspection tool like JSLint, JSIN. You can do further static analysis. You can do syntax transformation. How many of you are familiar with CoffeeScript? Yep, CoffeeScript is a form of transforming one syntax to another. And then you can also do a dynamic analysis. So let's take a look at the standard tools that you can apply to your project. So obviously, I already mentioned this. With parser, you can get the understanding of how JavaScript engine look at your code. And then you can also see whether your code is valid or not. So again, this can be run online. Here it is. So if you write bad code, then there will be a warning there that you're trying to do something wrong there. So this is a live example. It's also available as a grunt plugin or anti, so you can insert it in your workflow. How many of you here minify the code and then just blindly trust that minified code? So you still need to test it. So validation is the minimalistic thing that you can do, because the minified or transformed or converted code, that needs to be a valid JavaScript code, because otherwise the browser will refuse to run it. So you can also use this to validate the strict mode. How many of you here use strict mode exclusively? Good. Hopefully, more and more people adopt this. For example, in my fragment here, I declare color twice. In this example, it's very obvious, but sometimes your object is very, very large, so it's not really obvious that you already duplicate the properties. And you can again do this via the syntax validator, because if you pass the code in, and then you get the warning if there's a duplication there, or if there's a strict mode problem. I'll come to that. That's exactly the next slide. So validator is different than linter. For example, a syntax validator doesn't care about your style guide, because it's just like the browser will consume your code whether it's minified or not. That's what the validator does. So the purpose is just to as a step for you to know whether the browser will accept this code or not, and therefore it works well on minified or generated code. Sometimes you make mistake like this where you have a typo there, and then it leads to global leaks. And if you have a parser, you can walk through the syntax tree and then find out an assignment to a variable that has never declared before. And there's already a ready-made project for this called leaky. And if you run this, it will point out the problem there, that your variable has a typo. Of course, another problem with the same code fragment is that you declare a variable and that's unused. And again, you can build a tool. Obviously, someone already has done this. It's called unused, that walks through all the assignments, expression, etc., and then try to find out a variable that is not being touched at all. This will be valuable if you want to refactor code, because then you can throw away all the temporary stuff that you created but never got used. Again, all this protection layer can be placed in many places. One of them is the CI server. So if you run this syntax validator, it can output something compatible to JUnit XML, so you can plug in directly to many CI server like Jenkins. You can also use pre-commit hook. How many of you here familiar with pre-commit hook? All right. So it's essentially a script that will be invoked by Git before your changes are checked in. So if that script returns error, your commit will be blocked, so nothing will happen. So in this case, for example, I go through all the JavaScript files and then validate it. So if one file is not valid, it has a syntax error, then it will bail out, and therefore your change will not be checked in. This is fantastic because people forgot to run tests, and the best way is just to automate it. So again, this is one way for you to protect yourself so that bad code should never, ever, ever enter your repository at all. This is your Gandalf moment. So we have valid code. It passes your validator. It passes probably JSLint, JSIN, but then you want to understand how readable, how maintainable the code is. So there's some project called JS Complexity. You can go to this site, and there's also command line tools that allows you to run this via Node.js. If I write this code, it's all one line, but it knows that logically the number of lines of code is 4 because in different words you will have written it as if it consists of 4 lines instead of just one huge line. And then there's all this maintainable index and then cyclomatic complexity because the complexity of the code can be computed by all the various branches in that particular code. So you copy and paste your code to this site and you get the complexity number, or you use the command line tool and you get the all these various metrics. You can force this in your code because with this few lines of code, it will try to find out a particular complexity and metrics of every functions in that file. Yeah, I think I can run an examples here. So if I run npm test, one of the steps is to invoke this complexity analysis and then dumps here. These are the most cyclomatic complex functions. So if you try to improve the maintainability or readability, these are the functions that you should refactor first. So because they are, according to these metrics, quite complex. Again, if you track it over the time and you look back at your history, you can find out which function gets more complex or which function should be simplified. This should help you to find a better judgment on where you should spend your time. There's a fantastic tool called Plato. It's made by Jared Overson. I think it's here. Yeah, there. If you have question about this tool, go to that guy. So the idea is that instead of just numbers, you can get a beautiful chart. And the way to do this is by just running Plato. I think I have it installed. So it runs some analysis on your code and then come up with this summary of total line of code and maintainability and then all the charts and the estimated number of bugs and all files and so on. This is one file, so it's not really impressive. But if you have tons of files, is this from jQuery? Yeah, this is from Sizzle jQuery, and you get this beautiful, colorful charts that you can give to your managers or someone that likes colorful stuff. So again, tracking this over the time gives an understanding of how your project evolves. For example, if the estimated number of bugs, this is just estimated by the way, keep increasing, then you might want to do something. Obviously, all these problems can be avoided if your ID of your editor, your environment, gives some feedback at the first place that you're doing something wrong. A lot of you probably use fantastic ID that has autocomplete support. And one of the exciting project is from Eclipse Orion. How many of you heard this? So that's kind of web-based ID on the web. and it has something called content assist. That's a term for Eclipse term for smart autocomplete. Microsoft call it IntelliSense in Visual Studio. In this case, it analyzes your code and then try to infer various types and properties and so on, and it can complete your typing. So I think do I have it somewhere? Anyway, let's come back to that later. So another nice thing is that you should get feedback as you type. For example, it's visible. Yeah, there's a yellow highlight there. I think I can demonstrate this. So if I put the cursor here, then it highlights all the occurrence of that variable. Same case with this one and this one. So it's really usable to find, where all these variables are being used and declared and so on. You can see also on the right gutter here, you can jump to that other references. And this is obviously very useful if your program is long. It's also understand all the scoping of variables. For example, I create a function here called foo. So it doesn't highlight the function parameter because it knows your variable shadows that parameters. So you can build a lot of cool stuff with this. One of them is scope visualizations, a nice project. Yes, levels. You can try it at this URL. So if you go, I think Douglas Crawford had this idea some months back where the editor should tell you that this variable has this scope, and we can do that by color coding. So if you go to this URL and then type your code, and then you can see the scope of each object, each identifier, each variable, and each function. You can also use this for some sort of semi-automatic refactoring. For example, if you want to rename the variables. So if I don't like the name shuffle here, they can just change it to, for example, X, and then it'll change all the right occurrence of that. Again, this understands scope. So it won't change the function parameters. So this is wrapped in a micro library that I call ES Refactor. And rename refactoring is usually a two-step process. First, you need to identify all the function or variables. And you can use this API, and then you can rename this. So with this micro library, you can do some sort of automatic refactoring on your code because you can follow a certain convention that applies to your project. And let's talk about source transformation. So I already mentioned minifier. That's the obvious form of transformation that I call as regenerative. So basically, the source is consumed by the parser. There's a syntax tree, and there's a generator that consumes that syntax tree and generate a new source. There's another things which is I call as non-destructive. This does the modification in place. So after it obtains the syntax trees, it doesn't try to generate a new code. It just try to change bits and pieces in your original source code, much like how you do editing. So let's take a look at the code generator, how we can use that. So one of the applications is dynamic code coverage. The way we do this is by instrumentation or adding instrument to your code. So if I have these 2 lines of code and you use this tool called Istanbul, how many of you here already heard about Istanbul? Oh, all right. So Istanbul is a code coverage tool. So what Istanbul does is injecting extra lines of code into your code. In this case, it's just generated function variables that sort of track how a particular line is executed. So if a browser or Node.js or any JavaScript environment runs the code on that block, then it will also call this function. And all this function does is to mark, hey, by the way, I'm about to execute the first line. I'm about to execute the second line, and so on. Does everyone track code coverage in your tests? Sort of. So I have a hello world here, and if I run this, coverage. It also generates coverage report in LCOF format, compatible to most CI system. So here I can see that all the lines are covered, meaning that I execute both of them. And there's a nice numbers that says that, hey, this line is touched one time. I can also tweak my program so it won't be executed. And you can see there's a red flag there. And I just execute cover 2/3 of my statements. So this is very important because you want to write tests that exercise the most critical statements and expression and function of your code or your library or application. So there's a danger in just tracking the statement coverage. So the code block on the left and the right, they're identical, and there's a bug there intentionally because I'm just supposed to return P plus Q, not Q divided by Q. If you run the leftmost block, with code coverage, it will say that, hey, this code has 6 lines and you touch everything, which is not true because my test passes intentionally because Q is undefined there. As I run this increment function, I don't specify the value for Q, and therefore it becomes 1. If you write this particular code like in the right code block, then you'll see one problem because the one line there is not executed with my very minimalistic test case. But it's impractical to write all these branches and code to allow you to find out these bugs. So what we have to do is to do branch coverage, and fortunately Istanbul is pretty good at that. So if you run that code with Istanbul, you're going to see that there's a marker there, E, which indicates that else branch is not taken, meaning that there's never any call to this function where Q is not undefined. And therefore, you need to tweak your test case to cover both branches. Same case, if Q is always undefined, then if Q is never undefined, then there will be a marker I where that default if branch is not taken. How many of you track your branch coverage in your test suite? Yeah. Not a lot of people. I suggest you look at that because it's very, very important. I found a lot of bugs in Esprima itself by using Istanbul, which is built on Esprima. Again, this kind of inception. You can also place hard threshold on code coverage. For example, if you run Istanbul this way, it basically says that there should be at most 5 uncovered statements because it's -5, and 3 uncovered branches, and all the function needs to be covered. So if your test doesn't touch one of the branch, then there will be a complaint like in the screenshots. Uncovered count for branches 4 exceed threshold 3. So if you put this wherever you want to be defensive, from the editor integration to Git pre-commit hooks to Travis CI, everything. So there's no way someone can sneak in some code without writing some tests. There's a very nice sentence from DevGlass from Yahoo. If you think just lint hurts your feeling, wait until you use Istanbul. Your heart will be broken into 1,000 pieces because you think that you've done thorough testing in your project, but apparently you don't. So those are the standard tools that you can use. I mean, that's pretty much applies to any project, but just like JavaScript, as a very flexible and dynamic language, sometimes you have convention that applies to your project. For example, some project says, hey, you can only define a module, one module per file, and all these standard off-the-shelf tools will not track that because IDE doesn't know that your company mandates only one modules per files. So this is where bring your own tools makes sense. So I'm going to cover quickly 3 parts: consistency, convention, and scalability. String literal quotes. How many of you use double quotes? And the rest single quotes? If you switch from C or Java, then it's pretty hard to start using single quotes. And one way to do this is to automate the process of converting quotes from whatever to the one that conforms to your standard. It could be double quotes to single quote or vice versa. Or even give a warning if someone tries to write some string literals with quotes that is different than what is mandated by the style guide. Again, to do this is that if you paste this code to Esprima, it will dump all the list of tokens, and you can watch all those wrong codes and convert it, give warning, whatever. So this is a form of modification that is in place. So as the tools read your code, it doesn't generate a new code. It's just trying to find out all those quotes and then replace it with the right one. Obviously, in some cases, you need proper escaping. So style formatter. If you don't use IDE, it's kind of hard to track this style guide. Particularly if someone uses WebStorm, another guy uses Eclipse, some other guys use Emacs or Vim. It's not easy to conform to the same style guide. So this is where style formatter tools can be really, really useful. There's something called ES formatter, where you can pass in a gazillion of options. You want space after for, but you want line breaks after while, and do all this kind of unlimited combination. So it takes your source code and then it will format it. You can also use this as some sort of guards to check whether someone writes the code conforming to the style options or not. There's another project, unfortunately, kind of in the zombie mode right now, where instead of specifying how many spaces, indentations, and line breaks you want to have, you just pass a sample code. It basically says, hey, this is a good sample code. Please make the other code like this, which is pretty useful because you don't want to find out when to place braces and columns and so on. This is very useful for new engineers joining the project. Again, those tools can also give nice feedback so that you can learn that, hey, if I want to contribute to jQuery, this is the style guide that I need to follow. Application structure. If you get the code on the left side and you get the syntax tree and you walk through that, you can generate some sort of metadata. So in this case, for example, I can generate a metadata that says this code is basically creating an object. This is how it's called, and it has this to function, it has these properties, and so on. So you can use this metadata and then compare it to a certain convention that you have. I already mentioned if your convention is in this one particular file, you can only have this object, then you can check how many objects exist after you do this static analysis. Custom linting. A lot of time, the checks that are built into JSLint or JSLint, they don't necessarily cover all the convention that you have. In this case, I have placed certain restriction that comparison is you cannot use the double equal. It has to be strict equal. Obviously, this is already covered by JSLint, but just an example. So if you want to build that kind of check yourself, then you can use the code on the right side, which gets the code, parse it, and then walk through all the tests and see if it's using double equal or not. Surprisingly very simple, just a couple of lines of code. And you can build all these rules that hopefully track whatever convention that you have in your project. Boolean track finder. This is one of my pet peeves. How many of you are familiar with Boolean track? So here's the first example. Can anyone tell me what does false that mean? I mean, what does it do to my slider? So without looking at the API, it's usually very difficult. This is a real world example. I'm not making this up. Apparently, false there means you want horizontal or vertical, because who has ever seen diagonal slider? So if you have two choices, one of the way to do that is to use Boolean values. So if true means horizontal, this code means I create a volume slider that's vertical. Very difficult if you read the code, try to review it, and you don't have access to the API docs. By the way, code is usually written once, but read many, many times. So it's important to make this readable. Well, there's another problem. If you're a non-native speaker, like in my case, then double negative is always a problem. So if someone wakes you up in the middle of the night and says, hey, case insensitive false, does that mean lowercase a equals uppercase a? It will take like a couple of minutes to figure out. Like set hidden false, why not just call it set visible true, for example? Again, you need to be careful to have those kind of traps in your API, and one way is to build tools that exactly detects that. This is even more confusing, because what does it mean, like state, true and false? So apparently the first one means that you want to open the 3 items or not, and the second one means do you want to animate it while it's opening it? So jQuery has another problem with animation. I think stop, you can pass animation, stop, and true and false. And then everyone will be confused. Like, does that mean that animation stop first? And then, it's kind of confusing. But the biggest offense is DOM event. So if anyone can recite what those values mean, respect. So if you parse your code and then walk through all this crazy usage of booleans, then you can trap this kind of cases before it creeps into your repository. Another thing that people abuse is ternary conditionals, because you can have, question mark, colon, and so on and so on. In this case, it's rather, readable because you just use one variables, but in some cases, it gets really, really tedious and complicated. So again, if you find out the syntax tree for this code, you can see that there's a nested conditional expression inside another conditional expression, and so on and so on. So you can set up a threshold. For example, if you nested more than 3, then I will not accept it. Performance. This talk is not specific about performance, but I like to mention a bunch of things about this. So it's very important to have the proper measurement strategies. So sometimes you need to learn a little bit about statistics. Because imagine if you play Dart and then try to maximize your chance of winning, then you need to be both precise and accurate. Right? By the way, no JavaScript talk is complete without mentioning Dart, so that's why we have this slide. So it's not important just take numbers from whatever performance metric you have and then say, hey, this is 200 milliseconds. Is it precise? Is it accurate? You have to do a lot of analysis there. But what I would like to highlight is here that is fast enough for our purpose? If we measure it using stopwatch measure, is it good enough? Say we build an Android application and it has a functionality called sort, and you assign an engineer to work on that, and then you ask, hey, how's the speed? 10 contacts, 2 milliseconds. So it's fast for this purpose, but it doesn't say anything about how it deals with 100 contacts, 1,000 contacts, etc. So if you look at the code and then you see this code, this is probably good for a small number of contacts, but not good for real data. Can anyone tell what's wrong with this? Yes, it's a bubble sort. So again, the measurement time, as you try to find out how long does it take to compute something, to run a function, it doesn't say the full story. So you really need to deal with runtime complexity. And one way to do that, in this particular example, is that you inject an instrumented version of the array prototype swap. Because if you do this, then every time that function is called, you can find out how many times it's called. Let me run an example. So here's that precise bubble sort. And if I run, then it's done. But then you can see that this function is executed like almost 5,000 times. And obviously this one is just one time. We don't really care. Finding out executing the formal analysis on your code so that you can find out the complexity is usually very tedious. So this one is a nice complement to that. So with this, you can do runtime analysis, and you can see that our call to swap is not linear, and therefore this function is not necessarily scalable. You can also do this to annotate and execute and instrument every single function. For example, if you build a jQuery mobile apps, just an empty one before it launches to the screen, it needs to call 1,000 of functions. And you can see the full log there. Obviously, some of these functions are not dangerous. They're just setting up something, initialization, etc., etc. But the point is that if you plot this function as a function of time, then you can see whether someone is doing something wrong or not. So, for example, if some new engineer checks in the code that suddenly doubles this function call, then that warrants some investigation. So what about the future? Refactoring is usually necessary because you have repetitive code. In this case, there's not a problem where I try to copy some code and then make a mistake. Can anyone spot what the mistake is? This is very easy because I align everything. The code is very simple. That one, I should have changed it to Y2. So, but our set of tools right now don't tell us about this kind of mistakes. We can also use new syntax so that we can write non-ambiguous code. I usually categorize this to 2, exoskeleton, where you change the dramatically JavaScript with low-level JavaScript, Sweet.js, ASM.js, etc., or use something from the futures from ECMAScript 6, 7, Harmony, whatever. So I also want to see the trend where the tools tend to learn about your code. How many of you here use Google Now? Google Now is a fantastic application of artificial intelligence where it learns your behavior and tells you, hey, now usually you go home at 5. This is your commute time. It's 30 minutes. Although one time Google Now tells me to go to the office on Sunday, so it's not really smart. So if I keep writing or making the same mistake, and the tool should catch that and tells me, hey, you've done this like a million times, so please correct that. Or for example, if I start to edit a file and every indentation is 2 spaces and I start typing 4, then that should trigger a warning. Or if I call a function a million times and I check the return value, and one time I call that function and doesn't bother with the return value, or my code doesn't care about that, then that should trigger a warning as well. Or if I call a function with 4 parameters always, and suddenly I call it with only 2, that might be something that I don't want to do. Writing rules that checks your code for patterns that are dangerous, it's not always easy. So one thing that I'm working on is something called syntax query, where you can use jQuery, CSS selector style of declarative selector to choose particular code or to detect certain patterns. This way you don't need to write JavaScript. For example, it would be nice if I detect this kind of suspicious problem by just typing that one. And many more. We should have semantic diff and pattern matching and so on. So how many of you watched the latest Star Trek movie? I think it's pretty awesome. So obviously we don't have USS Enterprise at our disposal, but I wish that in the next 5 years we can explore a new level of language tools, some sort of our JavaScript version of Final Frontier, to keep us more productive and allow us to write more amazing web apps with the language that we all love. Thank you very much and enjoy the rest of the conference.